In this video, we'll be learning how to write exponential growth functions for situations that have compounded interest that is compounded continuously. So at this point, you should already have knowledge about how to solve exponential growth when you have interest that is compounded at a particular rate. So we might have it compounded weekly, daily, monthly, semi-annually, whatever that might be. In this equation, you had your starting value of A, that was the amount of money you had to begin with. Your N value represented your number of times it's compounded per year. Your T value was the number of years, and your R value was your rate. So that's what we currently know. However, there's also a situation where we can compound interest continuously. And that's what we're going to look at in this particular video. Now, what you probably don't realize is while there's some different variables here, this process is actually pretty much the same as above. There's just a different value being used because of the compounded continuously part. So first thing here is this value P. This value P is called your principal. Principal is a fancy way of saying your starting amount. So it's really the same thing as your A value. It's your starting amount that you have to begin with that you are investing. You then have your rate written as a decimal, which is the exact same rate you're using up here. It's an annual interest rate that you turn into a decimal so that you can use it in mathematics. Your T value here is still your number of years, so that part hasn't changed either. The only big difference here is this part with your rate right here. So you'll notice here that instead of being inside of these parentheses, your rate is now up in your exponent. And then from here, we also have this E value. So we're using the natural base E as our base of our exponent. So this PERT equation, as we call it, you can see how it says PERT right there. The PERT equation is used whenever we're going to compound something continuously. And again, it uses a lot of those same values, but it uses the natural base E as the base of our exponent, and then the rate moves up into the exponent with T. So let's walk through a couple of examples together here. This one says, your parents invest $12,000 in an account when you are born to give to you when you turn 18. If interest compounds continuously, so its interest compounds continuously, at an annual rate of 6.88%. Because it says continuously here, we know we're going to use this PERT equation. And we're going to need to find P, R, and T eventually in order to find the amount of money we have now. So P, remember, is your initial amount or your principal, as we call it. Your principal amount, your beginning amount, is $12,000. So P is going to be $12,000. Then your rate is your annual interest rate, which in this case is 6.88%. And we're going to turn that into a decimal. So we take 6.68, divide it by 100, and we get 0.068. So now we can put all of this information directly into our equation. So we have A, which is the amount that we're going to be calculating, is equal to our principal of 12,000 times the natural base E to the power of 0.068 times T. So that is our equation that's going to be calculating how much money we have over time. Now here it says find the balance in the account after 18 years. So here our T value is going to equal 18. So if we substitute this value into our equation, so we have E to the power of 0.068 times 18. We take our calculators, and remember that E button is going to be, if you press second and then LN typically is where you find E. So we type in 12,000 times, then we do our E button to the power of 0.068 times 18, and we close off that parenthesis. And as we do that, we see that after about 18 years, the amount of money we have in our account has grown significantly to be about $40,809.16. So just by letting that money sit there, it was able to grow to over 3 times its size. And as a result, we have a pretty good investment that we can continue investing at the age of 18. So let's look at example 2 here. It says you recently received $10,000 and have decided to invest the money. You have a choice of investing the money in an account that compounds continuously at an annual rate of 7.6%, or an account that compounds daily at an annual rate of 7.9%. Write an equation for each and determine which account is better if you plan to remove your money in 8 years. So let's start with situation 1. Because I'm compounding continuously, I know I'm going to use this equation that's A equals P times e to the power of RT. So that's the equation I'm going to use. Now I need to find the values for P and R to start. So I know P is equal to 10,000 because that's the value that we started with, and R is equal to that 7.6 divided by 100, which is 0.076. So we can substitute all of those values in, and we find that the amount that we have after a certain amount of time is calculated by the equation 10,000 times e to the power of 0.076 times t. So this is our equation that is going to calculate how much money we have over time. Now, in this particular situation, we know that it is taking place over 8 years. So we have t is equal to 8. So we're going to substitute that value in to find the amount we would have after 8 years. So we have e to the power of 0.076 times 8. So now if we utilize our calculator here, remember that that e button is attached to the ln, so you do second ln, then you do 0.076 times 8 and close your parenthesis, and you find that after about 8 years, your account currently has approximately $18,367.54. So that's situation 1. Now if we take a look at situation 2, we notice that this one compounds daily. So we're going to have to use the equation that uses y equals a times 1 plus r over n to the power of nt. So it's a different type of equation because it's a different situation that's compounding in a different way. So here our starting value of a is $10,000 still. Our n, because it's compounding daily, is 365 because there are 365 days in a year. And then your rate is going to be the 7.9 divided by 100, which is 0.079. So we can write our equation now. So we have y equals 10,000 times 1 plus 0.079 divided by 365, which we then take to the power of 365 times t. Now, for this one, I'm just going to type that equation into my calculator as is. So we have 10,000, then in parentheses 1 plus 0.079 divided by 365, all to the power of 365, and our t value here is going to be 8. So we're going to do 365 times 8. So we used our equation, we put 8 in for t here, we substitute it into our equation, and we find that after 8 years, we have a total of $18,812.41. So they are very, very close. While compounding continuously is typically better, this rate of 7.9% actually helps the compounding daily a little bit. And because we have more money after compounding daily at that higher interest rate, we would want to go with option 2, because option 2 is the situation that results in us making the most money over those 8 years.